So I will go off camera just so that we have a good connection, kind of. So apologies, please. I will go off camera, okay? So good morning, everyone. And I'm Veronica Tamu. I will be your instructor for today. Strange to say instructor, but okay. So today we are going to look at compute in the cloud, And this is the 4th module. Okay. So the objectives of today's module will, at least before we end today, we should be able to learn something about AWS Tenancy Models, identify the different Amazon EC2 instance types, the instance types and billing options, describe the benefits of Amazon EC2 auto-scaling, summarize the benefits of elastic load balancing, summarize the differences between SNS and SNS is simple notification service and simple queue service. Then we're also going to look at some additional AWS compute options, and if time permits, we should be able to go through some revision questions. Unfortunately, I have a hard stop at 7 p.m. So I hope we can go through this. So the last 3 modules, you heard about AWS, you heard about the benefits of cloud, you heard about how cloud computing is the way that you can access services via the internet, and you can have compute, you have storage, you have networking, you have all sorts of services that you access via the internet. And today we are going to look at compute. And the compute service in AWS that we're going to talk about is the Elastic Compute Cloud, Amazon Elastic Compute Cloud, which is abbreviated as EC2. And if you look, normally when you look, if you look at architecture diagrams, you will see this icon, which indicates that it's about Amazon EC2. And in simple terms, Amazon EC2 is simply a computer in the cloud at an AWS data center. So if you think of it in basic terms, it's just like a desktop computer that you have, but it's just placed in it's placed in the cloud at an AWS data center, or if you are with Azure or Google, it will be placed in their own data center. Of course, they might not call it Amazon EC2. They might give it, it might have a different name there. So essentially, if you compare your basic computer and Amazon EC2 in terms of the components, you will see that looking on your right, on your left, you see this is a basic computer. A basic computer has an operating system. It could be a Linux or Windows. It has a processing power, which you call a CPU. But if on your right, you have an EC2 instance component, really the simplified version of it. So for operating system, you have for EC2, if you are comparing to a basic computer, Linux or Windows, you have AMI, and you subsequently hear about AMI, which could also be a Linux or a Windows AMI. Then you have processing power with CPU, which in EC2 is an instance type. Then you have a hard drive, which is your local storage. In EC2, you have an EBS. You get to know about that also. And then you have a network card, which gives you access to the internet. And in EC2, you have IP addressing, which gives you access to the internet. Then you have also a firewall in your basic computer, and in EC2, it will be a security group. Then you also have a random access memory. So in a nutshell, you see that the components are almost the same, they are similar, they do almost the same thing. So you then think that your EC2 is like a basic desktop computer that you use, but then it's in the cloud. So again, your computer always has a hardware, which is the CPU, the network, and devices like storage and other things. And then it has an operating system. Here it's the Linux one, but you could have a Windows operating system. And then you have, in the Windows, they call it Linux is a kernel. And then you have applications that run on it, on top of your operating system, which could be your Word, your PowerPoint, your WordPress, for example, or you have a music software on your computer. So your operating system always runs in a privileged mode, which means the privileged mode means that it has access to this hardware, the CPU, the network, and the devices. Then your application will run in a user mode. Your application will not have access to, let's say, the underlying hardware, the CPU, the network, and devices. It just comes in, use the operating system, and then based on what you want to do on it, you get your processing power and all of that, but it doesn't access the underlying infrastructure. So this is how it looks like when you look at a computer. And as you know, technology will always advance, and what made it possible for cloud computing to be as popular as it is another kind of technology that came up that allows, let me just go back a little bit. In this scenario, you can only have one operating system that is using your underlying hardware, your CPU, your network, and your device. As I mentioned, with the advance of technology, there was the introduction of a hypervisor. The hypervisor is, if you get to understand virtualization, this is how cloud computing works. And that is what gives it an upper hand, that with cloud computing, there is the possibility to have this hypervisor, and the hypervisor is what interacts with the underlying underlying infrastructure, like the CPU and the network and other devices. And this gives it the opportunity for you to have not only one operating system, you can have several operating systems sitting on a host, and this host here is the hypervisor, sitting on a host, and then you will call it a guest operating system. So you have guest 1, guest 2, guest 3, and then it's also the same as you have different applications that are being that are using the different guests. So you have here maybe application 1 that is using guest 1, application 2 using guest 2, and this gives it room for it to, be able to distribute this underlying infrastructure here, rather than just one guest or one operating system using this infrastructure. You have the possibility of sharing the infrastructure, because again, you're able to allow, it allows you to use a physical machine's full capacity by distributing its capabilities among many users or environments. So the hypervisor here then becomes the brain in charge of allocating hardware resources to the guest operating systems. And this is really the foundation of cloud computing, yeah? So keep this in mind as we go ahead, that you have a host, which is the hypervisor here, that acts as the brain in allocating hardware resources to the guest operating system. And in this way, you're able to use this enormous, you're able to use the full capacity of your server or of a physical machine, rather than just one operating system that is using this, and then you have the capacity not fully used. So hardware virtualization for cloud computing, as I mentioned, has come a long way. And as I was reading, it's something that was already there in the 60s, but as cloud computing became popular and the technology improved, I think it became more and more used in around the 2000s. So, and in AWS, the latest hypervisor is the Nitro one, which uses everything to provide a new hardware-assisted hypervisor that is easy to use and has near bare metal performance. And this Nitro has security really at the level of the chip. So, and it is the underlying platform for EC2 instances. You can read more about AWS Nitro system, and there is a link here for you. Are we okay? Okay. So again, we have the Amazon Elastic Compute Cloud, which is a virtual machine in the cloud. You have the physical servers in an AWS region. Last week you heard about the global infrastructure, and there was a mention of regions, there is the zones, and then there is a data center. So in a region, you have your host server, then you have your hypervisor, and then you have the guest one, guest two, guest to whatever power, and your guest here is always the guest operating system. And yeah, so this is how your Elastic Compute Cloud will then look like when you have in a region. So this again is like you have your host and you have your EC2 sitting here. This is really how a data center will look like. You have like so many racks of servers, you know, where you have the infrastructure. You have the infrastructure, and then you can create an EC2 instance. When you log in, you just come in and create an EC2, which is a computer that is sitting somewhere in the data center, rather than you using it like a physical machine. You have it sitting in the cloud. So this again, this is a data center. The first one, an AWS data center. Yeah, you can read more about it. And we did touch last week about the global infrastructure. So now we go a little bit to one of our objectives of today. That was really like a background to set the pace for the presentation of today. So tenancy determines who is the owner of a resource. So you should think of tenancy in terms of housing. So you can either have a single house, you can either live in a single house, like you can see in the picture here, or you live in a complex where you have apartments where different people are staying and in apartments, rather than living in a single house. So if you have a house, then you consider that it's a dedicated tenant. And if you are living in an apartment, you have a shared tenancy model. And this is how in AWS, this determines who is the owner of a resource. So you're either a dedicated tenant or you share their tenancy. You share tenancy with other tenants, if I can call it like that. So AWS shared tenancy is the default model when you're launching an EC2, yeah? And here multiple customers will use the same piece of hardware, even though they don't have to interact with each other, yeah? And then you remember that there is a host running on it to handle the CPU or the memory or storage that goes to each guest operating system. If you come back here, you see, so you have a hypervisor, you have the guest, you have at least 3 guests here that are using the same hardware, and the hypervisor is then responsible for determining how much of the CPU network or devices or storage, for example, will go to guest 1, guest 2, and guest 3. So here, this is how it looks like. Sorry, I even forgot I had this. So you have virtual machines, which are EC2s. You have the instance store, which is like the storage that comes with the EC2. You have the random access memory. Then you have your CPU, the central processing power unit, sorry. And then you have the guest operating system, which are now sitting on this hypervisor. And here you have the situation of a shared tenancy. Let's, for example, here there is a host 101, where you have these guests, which are the operating systems sitting on the hypervisor and the different applications running on there. And this is virtually, here you would then have a virtual EC2 instance here. And it could be, the guest operating system could be a Linux or a Windows. Then you have dedicated tenancy. I mentioned that in dedicated tenancy, if you look at it like someone living in a house alone, you know, you don't share it with anyone. You run your hardware specific to your account, but of course it comes with a price. You can't compare the price of a single house, yeah, to an apartment. It will always be more expensive than when you share, right? So, and this is usually always because, you know, you have licensing restrictions, and which you are not allowed to run in a shared tenancy model. Then you always go for a dedicated tenancy. And sometimes you have your own licenses, because again, it's always expensive when you already have like a license, and yeah, you can't just throw it away. So there is a possibility now to bring your own licenses and run on AWS using a dedicated tenancy. And in other circumstances, it could just be that because of regulatory compliance, you must use a dedicated tenancy. You are not allowed to use a shared model. So, and there are 2 different options for a dedicated tenancy. You have a dedicated host and a dedicated instance. So for a dedicated host, you kind of purchase an entire physical host from AWS, and that is built to you on an hourly basis. Yeah, this might seem like how you manage your on-premises infrastructure. So you control the hardware where your instances are hosted. Then it allows you to use your own licenses. I've already mentioned that, yeah. And it is integrated with AWS License Manager. This is another service in AWS that helps you manage software licenses, you know, including Microsoft Windows Server and Microsoft SQL Server licenses. And you may not mix EC2 instances types on the dedicated host. So in this case, this is you have this host 102, which is dedicated to an account, and only one guest can use the hardware infrastructure here. Yeah, remember that for a shared tenancy, you have several hosts that are using the hardware. Then you have the dedicated instance, and this will run in a VPC, and that will be that is dedicated to a single customer. Yeah. So in this instance, your instances are physically isolated at the host hardware level from the instances that belong to other AWS accounts. And with dedicated instances, you may share hardware with other instances from the same AWS account that are not dedicated instances. So you don't have any control over the placement of the instances, so they can be moved from host after you stop and start. So in a dedicated instance situation, you have your hardware here, and then you have shared instances, but this must be coming from the same account. And this is different from a dedicated host where you can only run one instance at a time. Here you can share, the instances will share the hardware, but those instances must be coming from the same account. Is it okay? Is our understanding fine here? Can we continue?
Yes, Vero.
Okay, good.
Yeah, I wanted to ask something regarding this dedicated instance.
Yeah.
It means the dedicated instance, you are, for example, I am the dedicated instance. I am responsible for my services. Then I can decide to share to another clients, or maybe.
So here, not sharing with here the instance, the instances can share the hardware if those instances are launched from the same account.
Okay, then I get it clear now. Thank you.
Yeah. You are not sharing with other clients, with other people, because in that one you are in a shared tenancy module there. But here, if you give access to someone who is working in your account, yeah, then they can launch an instance, but it cannot be a separate account that can use a dedicated instance. The shared hardware here is that the instances in the same account can share the hardware. Yeah, it's clear?
Yes, thank you. Thank you. I get it clear now.
Okay, so EC2 instances are virtual machines. They can run on an EC2 host, and the host could be a shared host or a dedicated host, and it runs in a single availability zone. So last week we heard about global infrastructure, the region, the availability zone, then the data center, and EC2 is one of those services that is a zonal service. It can only run, you cannot, you only have to run it from an availability zone. So it's a zonal service. And if an availability zone fails, then the host fails, then your instance will fail. But of course, as you get to architecture, you will always then have the situation where you have to take care of not having your EC2 to fail by, let's say, running it in more than one availability zone. Okay, you come to understand that. So again, you have an AWS region. We mentioned it last week. And then in a region, you have an availability zone, which is AZ1 and AZ2. So you run your your EC2 instance in an availability zone 1 and availability zone 2. And as I mentioned, if you run it only in availability zone 1, and if it fails, then everything fails. So there's always the advice of, running it in at least 2 availability zones. So an availability zone is 1 or more discrete data centers with redundant power, networking, and connectivity in an AWS region. Yeah, we touched on this last week. So what is EC2 good for? Yeah, like for most companies that are moving to cloud, they have their traditional operating systems, and with applications, they will easily use EC2 because they already have their applications running in a traditional operating system. You can easily move it to AWS and you move them to run on EC2. And if you have an application that has to run for long, that needs compute, then you can use an EC2. You use it also for server-style applications and for monolithic application stacks. And in the course of today, we are going to hear about what a monolithic application is. And then you can also migrate application workloads, yeah, or can be used for disaster recovery. So an Amazon machine image is a template that contains the desired software configuration of an instance. So it's like when you in your normal traditional computer, when you get your computer, you have a disk that you usually will use to install your operating system. So the AMI is like that, because that disk has everything to have your computer up and running with the right operating system. So an Amazon machine image is similar to that disk that you insert in your computer to install your hardware. So it has the operating system, the applications. Optionally, it could have applications. Then it has additional supporting software and the root device boot volume. When you start a computer, it needs to boot. And then you can, once it has booted, you can then add other storage volumes to it. So whenever you're launching an EC2, and I will go out of my of here a little bit. Hopefully, I'm still having my So here, when you come to I'm here on the console, and if you come, let's go to EC2 for example, and you want to launch an EC2. So if you want to launch an instance, the first thing that you need to do is to select an AMI, and this AMI has your operating system, which could be, it's taking some time. So if we want to create an instance, launch an instance here, it's loading a little bit. Yeah, so this one has a quick start here. So you have your Amazon machine image, which could be Linux, Mac OS, Ubuntu, Windows, Red Hat, or SUSE here. And then the first thing is you always have to choose this. Yeah, and there are so many of them if you browse. That was the quick start for launching an EC2, but if you have to go like step by step, you need to first of all select your AMI. You need to select your which could be a Linux or a Mac OS here. And there are ones that, you can have the free tier attached to it, meaning you can run it for some time, for at least a year without paying. Yeah. So when you want to launch your EC2, you need to first of all select this AMI, and your AMI has the desired software configuration for your instance. Let me go back. Oops. Go back to the presentation. Yeah. Okay. So the MI components, you have the boot volume, which describes what will be used as the boot volume for the instance, and it could be an EBS volume that you attach to it, or it could be the local instance storage volume, because your EC2 always comes with an instance storage, and the operating system could be Linux or Windows. So yeah, so that is that about that section of our presentation today. So we've mentioned AMI, which is like the first, that when launching an EC2, you need to first choose it, and it has the configurations that you need for your instance. So now we're going to look at the different instance types. Yeah. So the different instance types, it's like, they will depend on the type of workload that you have. It's, this is, I don't know, wait, let me go up a little bit and centralize this. This is going out of screen, but okay. No, I don't want to start from. Sorry about that. Okay. So like any, the instance types that you select will depend on the kind of workload that you have. So here I'm just giving a comparison to, let's say if you have a construction project, you have different, let's say you're constructing the road, you have different machines that will do different things. Yeah. So maybe there are ones that are lifting heavy things. There are ones that you have to move, like in this case, you need to have a lift. Yeah, you have a tractor that needs, you have big carriage, so you can carry a lot of things. You have the one that has to dig. So same for an EC2 instance, you have different EC2 instance types depending on the type of workload, the computer workload that you need. So and the instance types, you have the different sizing and different configuration options. So you can have an operating system depending on the type of work that you want to do. You can decide if you have a Linux, a Windows, or a Mac OS, or you need Ubuntu, or you need a Red Hat, or you need to decide on how much compute power you need, what CPU do you need, what random access memory that you need, how much storage space do you need. You could have storage based on whether it's a network attached, like the elastic block storage. You have elastic file system. You also have the hardware that, as I mentioned, you have an EC2 instance store that comes with your EC2. So depending on what you need, you could have the network card, the speed of the card, whether you need public IP addressing or you need private IP addressing. So those are the different things that you have to consider when you're choosing your EC2, the sizing and the configuration options. So you need, and some of these already come with your API, AMI, sorry. So Amazon EC2 provides a wide selection. As I showed you, there are so many of them, and depending on the type of workload that you have, you need to choose what fits your use case. And the instance types will, again, have varying combinations of your CPU, the memory, the storage, the network capacity, and this really gives you the flexibility to have different mix based, again, on the kind of workload that you have, the kind of applications that you want to run, yeah? And each instance type includes one or more instance sizes, allowing you to scale your resources depending on your requirements, yeah? Again, that is the beauty of cloud computing. Sometimes if you have to compare it with the normal, the traditional computing, you have, sometimes you have your computer, if you've installed, let's say Linux, or you've installed Microsoft, or you've installed Windows, you are just stuck with it. Let's say you need something now that needs to work on a Linux computer, you then have to buy another computer and install a Linux operating system with it. But with cloud computing, you have the choice, depending on what you want. You can go on and launch a computer. As I mentioned to you, EC2 is really like a computer that is sitting somewhere on the cloud in the data center. So you can go in there and launch based on what you need. So the first instance type here is the general purpose. And this is the default one that when you're launching an EC2 instance that you have. And it's also for diverse workloads and equal resource ratio. So here it provides you a balanced compute, memory, networking, and it can be used for different workloads. And it's ideal for applications that use resources in equal proportions, like the web server. So like if you're running a website, yeah, and a code repositories where, where developers put up their codes. So the general purpose is really used for a variety of diverse loads and provides a balanced compute, memory, and networking resources. Then you have the compute optimized. Yeah, compute optimized are ideal for compute intensive applications that have to have high performance processors. And the use cases here are for media processing. You might have videos that need to be processed, then you need a lot of compute power, and modeling for scientific modeling and machine learning. We've all been hearing a lot about machine learning. Those are kind of computations that need high processing power. You have gaming and you have batch processing workloads. This is for compute optimized type of instance. Then you have the memory optimized, and these are designed to deliver fast performance for workloads that process large data sets in memory and in some database workloads also. And the use cases here are for high performance relational and non-relational databases. And we will hear about databases in the course of this training. And then you have distributed web scale cache stores. You have applications performing real-time processing of big unstructured data. Again, you also hear about this when we talk about databases. So in these situations, you will need a memory optimized EC2 instance. Then you have accelerated computing. For accelerated computing instances, you will use hardware accelerators or core processors to perform functions like graphics processing, data pattern matching, and more efficiently than is possible with a software running on CPUs. And CPUs here is more about compute. So you need an accelerated computing for this kind of use case. So for like machine learning, computational finance, speech recognition, and drug discovery. So those one need fast computing. And in that situation, you choose an EC2 instance type that has accelerated computing capabilities. Then you have storage optimized EC2 type, and here those are designed for workloads that require high sequential read and write access to very large data sets on your local storage. And again, you hear about storage in the course of time. And they are optimized to deliver tens and thousands of low latency, random input-output operations per second to applications. And the use cases for this type of storage optimized EC2 instances are data warehousing applications, cache for in-memory databases, e.g. Redis, you hear about it. And then you have distributed file systems. So those are the different types of EC2 instances. And if you go again on your console, I don't want, for the sake of time, if you go to your console, you should be able to see, you know, the instance types. So here, if you come here, you can see the different instance types that you have. So again, while studying, you can always come on your console if you already have an account to look at what is there. Yeah, this is it's a bit slow, but I will come out. I've just shown you that if you come here, you can have, yeah, these are the different types of instance types. You have T2 micro, and if you look here, you can see what the CPU, if I can just, yeah, the CPU that it needs here. You have one virtual CPU, you have the memory, the different type of the memory there. And then as you go along, you see, for example, depending on your workload, you see the T3X 2X large here. It has 8 virtual CPUs, and the memory is 32. So again, depending on what you need, you can choose your instance type. If you want the one that is storage needs more storage, you have one here that has 640 gigabytes of storage. So this will be storage, kind of a storage optimized EC2. Sorry, instance type. Okay. So let's go back to our presentation. Start from here. Yeah. So here we are. Any question on the EC2 types? Okay, I take silence as there is no question. Okay.
About the general purpose, I want to know which type is good for us to use. Is it T2 or T1? I don't know. Other size, I don't know.
Yeah, so for the general purpose, I said for general purpose, you have a balance of your of CPU, of CPU memory, RAM, and maybe network or so. For that, I would think, and Ban, you can help me here. I would think maybe a T1 micro or a T1, T2 nano will be okay, Ban.
Yeah, regarding general purpose, T it will really, as you say, the first thing, Herman, is when you say general purpose, is balance, kind of. You can't say the computer is high, you can't say the memory is high. So it's more of just balance, right? So it's not for compute intensive workloads, just like it's not for memory intensive workloads. Now, type of instance that will support that, you can always see that from, I know if you go, maybe you see that there are some like Mach 2 and others. So those will vary. So when you look at the memory and I'll say the memory and the
CPU.
Oh yeah, CPU, you see that it's balanced, right? Yeah, but for those other ones like the T ones, there are just low grade that have just been created for more of testing, right? Those T ones but you can still have one that the key thing is if you are picking one for general purpose, you won't have it maybe with heavy memory, with heavy compute. It will just be will have those factors balanced. But it doesn't mean that it cannot have up to, for example, 32 gigabyte. It can have 32 gigabyte, but then the processing power will also be balancing that up so that it's not just like a memory intensive. So just keep in mind that it's a kind of balance. The components in it are kind of balanced, not really. One is not, yeah.
Yeah, I mean, if you come to this kind of the example I mentioned about storage where you had 600 and, or is it 400 and something, 640, you will clearly see here that it's really a storage optimized and based on what you need. If you need a storage optimized instance, you then have to go for this type, right?
Yes, if you're looking for storage optimized, you go for those that,
okay. Is it clear?
Thank you.
Yeah.
Okay.
I'll also, there's also the Herman, I'll also share the link as usual that you can look on the AWS documentation and you'll see those examples, so much more clearer. Okay.
Yeah, that's fine. Thank you.
Okay.
Okay, good. So now we are going to look at EC2 instances and the pricing options. So at the beginning, we did have we mentioned your first class. There was the mention of cloud computing is IT services over the internet on demand. Yeah. So on demand, as you need, you go and you get it. So EC2 instances pricing, of course, falls in that respect, that also once you need, you go, you create, you use it as you need. So you have the on-demand, which you pay you pay per hour or per second, and per hour here it's for Windows instances, and per second is for Linux instances. And please take note of this, and it does sometimes you have it as you prepare for your exam, that you can have a question around this, that the on-demand, the per hour, which of the instances operating system you pay per hour and which of them is per second. It might come in that way, but know that for Windows you pay per hour, and for Linux you pay per second. And this is for short term. Maybe you are testing, you want to test, you've developed your application, you want to test if it's working or not. You can you can go on the AWS and launch an instance on demand and just pay for that short time that you need it. And also when you have unpredictable workloads, you don't know if it will be extended, or if it's something that you will be doing all the time, it's unpredictable. When you need it, you go in, you use it. You don't have it planned that, okay, I will have to use it for a certain number of, for a certain duration. So again, on demand, you go in like I did. I went, if we were going to start or launch an EC2, you go in, I launch it, I start it, it starts running. And if I don't want it, I stop. Yeah, and then I pay for just what I've used. Yeah, I don't have any commitment there. I just pay for what I use. So that is on demand. Then you have reserved instances. So here you need to commit. You can commit for 1 year or 3 years. And this will be if you have applications that need consistent usage, and you know that you need this kind of usage for a year, you can reserve the instances. Or if you need it for 3 years, you also reserve it for 3 years, just how much you will need for your application if you know that you need consistent usage. But know that once you have committed to using it for one year, if let's say after 2 months, you see that I don't need it again, there is just no way out of it. You are locked with that commitment. Yeah. So when you're considering usage of reserving instances, think well, because you cannot come and say, oh, I don't want to use it again, because you need to pay for it because you already reserved it. So in those instances, if you really do not know how much if you will be using it consistently, don't commit. You better go for on demand. Then you have spot request, and this is spare AWS capacity that is discounted at like 90%. Yeah, you could have it discounted to like 90%. And this is for application with flexible start and end times. And meaning if there is high request after you've requested for spot instance, they can be taken away from you in like 2 minutes. You have a notification of, let's say, 2 minutes that you will not, that the spot instances are not more available to you. So if you have applications that are flexible with start and end time, that if you stop, you won't lose something, then you can go for a spot request kind of pricing. So here I also here you can also request for spot request or reserve instances and scheduled instances, capacity reservations. You have it on your console, and you can choose the one that you need. Okay, so the purchasing options for on demand, you pay for what you use, and the pricing per second for Linux instances and per minute for Windows instances, and the minimum is 60 minutes, if I'm not mistaken, for when you are using Windows, but for Linux you can pay. Then you have full control over its life cycle. You decide when to launch, when to stop, when to hibernate, when to start, when to reboot, or when to terminate. And that's the beauty of on demand. And as I mentioned, it's really for as you need. So there is no commitment, there is no upfront payment. And as I mentioned, it's recommended for short-term and unpredictable workloads that cannot be interrupted. And this is for when you're developing or testing applications on AWS for the first time. Then spot instance pricing. So I mentioned that this is instance that coming from spare EC2 capacity that is available for less than the on-demand price, and this could go to up to more than 90% of what you pay in on-demand. you bid a price and get the instance as long as it's under the price. So once it's above the price, if you want to continue using it, I guess you need to pay for it. And if you're not, then it stops. Then the spot price will always fluctuate based on the supply and demand. So, and this is based on the available unused AWS EC2 capacity that you have. You have 2-minute notification when the price goes above your bid. Again, if it goes above your bid and you still want to continue using it, you can always then pay for the price that that has been indicated. If not, then it stops. So spot instances are recommended for fault-tolerant, flexible, and stateless applications. For example, for spot instances, it will work well for big data, containerized workloads, continuous integration and continuous development, stateless web servers, and high performance computing batch jobs. And these are workloads that are not really critical. You can't use spot instance for a critical workload or workloads that cannot be interrupted, else you lose everything. Because again, you have 2 minutes for things to stop when your bid price is below what is now the price for the spot instance. So it's not recommended for critical jobs or databases. Then you have saving plans. The saving plan provides savings beyond your on-demand rates in exchange for a commitment of using a specified amount of compute power, and it is measured per hour. For there you have also the commitment to use it for 1 or 3-year period. And this term commitment results in savings of up to 66% of the on-demand cost. Then you have reserved instances. So this provides you with a significant discount of up to 75% compared to your on-demand instance pricing. The reserved instances also provide a capacity reservation. So, and it is assigned to a specific availability zone, therefore ensuring your ability to launch instances when you need them. So for reserve instances are recommended for application with steady state usage. You have applications that require reserve capacity, and if you are a committed customer for a year or for 3-year term, you can, depending on your kind of activities that you want to do, it will be best to have a reserve instance pricing, because again, you have at least up to 75% discount compared to what you pay for on-demand instance price. So for a reserve instance, you have standard pricing. It enables you to purchase reserve instances for 1 year or 3-year term, and it has a 75% discount compared to on-demand. You have the flexibility to change the availability zone, the instance size and networking type of your standard reserve instances. So then you have for reserve instance, you also have convertible pricing, and this suits best for if you need additional flexibility. So such as the ability to use different instance families, different operating systems or tenancies over the reserve instance term. So for the standard, if you choose that you are going to use a particular instance, then you are locked to it. Meanwhile, if you go for convertible pricing, let's say you were using a Windows operating system, and now you feel like you need a Linux operating system, you can change and go to a Linux operating system. And you have up to 45% discount on convertible reserve instances compared to the on-demand instance. For reserve instance payment, you have 3 different options. You can either have with not paying anything upfront, and then you're discounted on an hourly rate for every hour within the term, regardless of usage. So no upfront payment is required. And for standard instances, this option is only available for 1 year reservation if you have to do no upfront. And for convertible instances, you have the option, it's only available for a 3-year reservation. And of course, when you have no upfront, it means that the discount will not be as high as when you pay. If you take, for example, when you want to pay something, you go to a shop, you want to pay something, you want to pay the money all at once. Imagine you have a better discount than when you say, I want to borrow, let me put it that way. You want to take it and not pay something. Someone might, the person who is selling, even if they are going to give you a discount, the discount might not be high. So for no upfront payment, of course, your discount might not be high. Then you have partial upfront, say you pay 50% of it, and then you finish the 50% later on. Maybe your discount there will be like 40%. And so you pay a portion of it upfront, and then the remaining hours of the term are billed at a discounted hourly rate, regardless of usage. Then you have all upfront, you pay in full. Then maybe there you can even, for someone who is selling, I'm going to get this money at once, means I can also, give you a good discount, because at least you're going to pay some money that I can already use to do other things, right? So it works in that way. So for payment options, you can have no upfront, you have partial upfront, and all upfront. And all of them will have different discount rates. Then you have the purchasing option where you have a scheduled reserve instance. So you can schedule when you want to reserve your instance based on your needs. Yeah. So you purchase instances that are always available on a specified recurring time for a 1-year term. And you can launch it within the time window that you have reserved. Let's say you are performing some batch processing of things, and you say we always process on Fridays of every week. Then you reserve your time for that Friday. It's booked for you, and you pay for that time as for those instances that you've reserved based on that schedule that you have, So it's recommended for an application that runs during business hours, or for batch processing that runs at the end of the week. So let's say you only carry out the processing over the weekend. So you reserve at that scheduled time of the weekend. That's for scheduled reserve instance. Then you have a dedicated host pricing. Yeah, the price for dedicated host will vary based on the instance family, the region, and payment option that you choose. So you pay hourly for each active dedicated host, regardless of the quantity or the size of the instances that you choose to launch on a particular dedicated host. And you are billed for the usage of your instances. You're billed for the host that has been dedicated to you. Yeah. Then on-demand dedicated host pricing, you pay for each hour that the dedicated host is active or allocated in your account. And when you release when you release the on-demand dedicated host, you also terminate the billing. The on-demand gives you the flexibility to scale up or down without long-term commitments. That is for on-demand dedicated host. Then you have reserved dedicated host pricing. So just like the reserved EC2 instances, the AWS dedicated host reservation also provide you with up to 70% discount compared to the on-demand price. And you also have 3 payment options to choose when you purchase your reserved dedicated host. All upfront, partial upfront, and no upfront. And again, for the other one that I mentioned, for the reserved instances, you then pay the discount. The discount will be based on whether you're paying upfront, you're paying partially, or you are not paying anything upfront. It will be the same kind of comparison there. Then you have the dedicated instances, which run in your private cloud, your private, the VPC, on hardware that's dedicated to a single customer, and their billing is per instance billing. Yeah, and you can read more here. When you get the slides, you can read more about it. Yeah. Then the EC2 Mac instances allow customers to run on-demand Mac OS workloads in the cloud for the first time, extending the flexibility, scalability, and cost benefit of AWS to all Apple developers. So with EC2 Mac instances, developers creating apps for iPhone, iPad, Mac, or in a nutshell, all Apple products, you can provision and access Mac operating system environments within minutes and scale the capacity as needed, and can also benefit from AWS pay as you go pricing. Yeah, I showed you when we were looking at the AMIs that are available, and you could see that there is the Mac OS AMIs also. So for Mac operating system, you can also use EC2. So EC2 Compute Cloud for allow instances to run on demand for Mac. And the pricing here is available for purchase as dedicated host through on demand, and also through saving plans pricing models. And the billing for EC2 Mac instances is per second, with a 24-hour minimum allocation period to comply with the Apple software license agreement. Through on demand, you can launch an EC2 Mac host and be up and running within minutes. And at the end of your 24-hour minimum allocation period, the host can be released at any time with no further commitment. So with both compute and instance saving plans available, you can also run Mac EC2 for Mac at 45% discount on demand pricing with a 3-year commitment. So these kind of details are good to know, because you can have questions around this. So this is like a summary of the instance purchasing options. So you have the on demand, you pay as you go per second, per minute, and depending on the instance type. Then you have the spot instances, you request unused EC2 instances, which can tremendously reduce your EC2 cost. Yeah, greater than 90% is huge. Then you have reserve instances that will also reduce your cost but then you have to have, there is a commitment there of 1 or 3 years. Then you have dedicated host where you pay for the physical host, and that is fully dedicated to running your instances. Yeah, we mentioned when we were talking about the tenancy module, where you have a dedicated instance which is dedicated to your account, and you can run instances there. You share the hardware because it's in your account. Then you have dedicated instances. You pay per hour for instances that run on single tenant hardware. You have capacity reservations. You reserve capacity for your EC2 instance in a specific availability zone for any duration. And then you have saving plans, which reduces also your cost up to 60%, where you commit for 1 to 3 years, and you commit to using a certain amount of compute. And it's in the US dollars per hour. So you can again read more of instance purchasing options. There is a link here which you can go on for further information. Okay, that was that for the summary on purchasing. Then you have the dedicated host pricing. You pay by the second for the instances that you launch. For the on-demand dedicated host pricing. Then you have the reserved dedicated host pricing. You have at least 70% discount compared to the on-demand. And this is when you bring your own existing per socket, per core, or per virtual machine software licenses to reduce cost. And there are 3 payment options, yeah? Upfront, partial, and no upfront. Then you have the saving plans where you also lower your spend on dedicated hosts. Yeah. Flexible pricing and provides up to 72% on your AWS compute usage. This pricing model lowers prices on Amazon EC2 instances usage, regardless of the instance family, size, operating system, tenancy, or AWS region. Then you have per second billing. There you pay for what you use, and it takes cost of unused minutes and seconds in an hour off of the bill, so you can focus on improving your applications. Then EC2 usage are billed on 1 second increments with a minimum of 60 seconds. Similarly for on-demand, reserve, and spot forms in all regions and availability zone, and for the different for Amazon Linux and Ubuntu. So you have per second billing. For example, if you launch an instance, let's say you launch a Windows instance, you will pay per minute. Meanwhile, let's say if you've used just 30 seconds, you will still pay per minute for a Windows instance. But if you are using a Linux instance, if you work for 1 second, you pay for 1 second. If you work for 30 minutes, you pay for 30 minutes. So if you look at it, yeah, the per second billing also saves a lot for you. So any question on the pricing?
I think just to indicate there's a minimum of 60 seconds that you pay. Mm-hmm. So then after that, then per second, I think, based on what you have there, we'll just check on that. So there's a minimum of EC2 users bill on 1 second increment with a minimum of 60 seconds. Yeah. Mm-hmm. Yeah, just that everyone capture that. Yeah, that's fine.
Okay. Okay. So for the sake of time, let's wrap up. Then we have EC2 auto scaling. So EC2 is another service, and it works. It's a service that helps to ensure that the correct number of AWS EC2 instances are available to handle the application, your workload, and it can be the dynamic scaling, which responds to the changing demand, or you have the predictive scaling. So for auto scaling, it works with making sure that you have the correct number of EC2 instances depending on your on your your workload. So so you have an auto scaling group where, for example, you have a minimum of at least one EC2 that should be running. And if you desire to have 2 instances that should be running to accommodate your workload, but of course, if depending on your workload, you could go up to a maximum of 4 instances. So once your application is running, if it needs more resource, it will scale up and provide the resource that you need. And if the need for the resource goes down, it will scale down. So EC2 auto scaling in that respect helps that you have the right the amount of resource that you need as your applications, depending on their need, if there is a spike or if there is less needed. So it detects when the benefits of using auto scaling. It detects when an instance is unhealthy, it terminates it and replaces it with a new one. So when I mentioned that you need at least a minimum of 1 EC2 to be running, and you desire to have 2 that are running. But if the demand goes up, you have a maximum that you allocate, and then it spikes. Yeah. And so it ensures that your application always has the right amount of compute, so increasing your application availability. And then it also helps that as it scales up or down, it helps that it's optimizing your performance and cost. So with EC2 auto scaling, you can lower the cost rather than maybe not having enough of resource for running. It makes sure that you have a balance. If something is not good, it just takes it away and replaces it. Then you have AWS Load Balancer. It's a service that automatically distributes incoming traffic to the multiple resources, such as your Amazon EC2 instances. So when you have a low demand, and you have your auto scaling group here, you have it, so the first touch is your Elastic Load Balancer. So it acts as a single point of contact for all incoming traffic to your auto scaling group. So when there is a low demand, you just have 2 of them running, then it distributes load to the 2. Then when you have a high demand where you have increased your number of EC2 instances, you have now 4 running, and then your Elastic Load Balancer will help that, load is distributed to the instances as the demand comes in. Then you have, okay, you have monolithic applications and microservices. So your microservices, they all, okay, let's use this. Sorry. I'm sorry about this. Okay.
I think it's visible. Applications are made.
Okay. I'm not seeing very well. So applications are made of multiple components. And so the components will communicate with each other to transmit data to fulfill your request and keep the application running. So I mentioned before that there are monolithic applications where you have the different components, 1, 2, 3, 4 are working here, but here it is in really a tightly coupled together. And if a single component fails, then the other components will also fail and your entire application will fail. This is where you talk of monolithic application. Then microservices then come into where you have the components are loosely coupled. So if a single component fails, the other components will continue to work because they are communicating with each other. So so in the course of time, you also hear about loosely coupled applications or tightly coupled applications, but there is always the recommendation that you have your applications in a loosely coupled way, so that if each component fails, everything will not fail. And microservices are what are used to decouple your applications, to make them loosely coupled. And Amazon Simple Notification Service, which is a publish and subscribe service, is one of those kind of services that you can use to decouple your application. And it uses SNS topics. A publisher will publish a message to subscribers, and Amazon SNS subscribers can be web servers, email addresses, AWS Lambda functions, or several other options. So it's a service that is used for decoupling. Then you have the Amazon Simple Queue service, which is a messaging queuing service, and it is used to send, store, and receive messages between software components without losing the messages or requiring other services to be available. And in Amazon SQS, an application sends messages into a queue. A user or service would receive a message from the queue, processes it, and then deletes it from the queue. So SQS is used again to decouple applications. So it makes the components loosely coupled. So if, because of this, if one component of your application fails, the whole system does not fail. Then I just want us to touch a bit on additional compute services. So you have serverless computing, where I think you must have heard about AWS Lambda. It's a serverless event-driven compute service that lets you run code for virtually any type of application without provisioning or managing servers. That's why it's called serverless. So you only pay for the compute time that you consume, and charges apply only when your code is running, and the code will run maximum for 15 minutes. So you can run code for any type of application with zero administration. For example, when you're uploading an image to, let's say, to a website, that can trigger a Lambda to run a code to resize your image. So Lambda is a serverless compute service, no administration at all. Then you have containers, which provide a standard way to package applications, code, and dependencies into a single object. And containers can also be used for processing and workflows in which there are essential requirements for security, reliability, and scalability. And you have the Amazon Elastic Container Service, which is a highly scalable, high performance container management service that enables you to run and scale containerized applications on AWS. So Amazon Elastic Container Service supports the Docker containers, and Docker is a software platform that enables you to build, test, and deploy applications quickly. You can read more about this. Then you have the Elastic Kubernetes Service, which is a fully managed service that you can use to run Kubernetes on AWS. And Kubernetes is an open source software that enables you to deploy and manage containerized applications at scale. Then you have the AWS Fargate. Fargate, I can compare it. It's also like Lambda, but Fargate is a compute service for containers. So it works with both Amazon ECS and Amazon AKS. So when using Fargate, you do not need to provision or manage any server. So again, it's a serverless compute engine for containers. And then Fargate manages your server infrastructure for you, and you can just focus on innovating and developing your applications, and you pay only for the resources that are required to run your containers. So So you can actually click here when you get the PDF or the slides to read more about, of course, the EC2 and all the other aspects that we've touched today about EC2. Yeah. So I know we don't have much time. We have just 5 minutes. Maybe we can take 1 or 2 questions before we go, and I also let you know let me know if you have any other questions before we go to any revision. Are there any questions? No? Okay. Means we can take 1 or 2 questions before we have 4 minutes. But there are so many questions that even if we don't go through, you can go through by yourself. I think we all can read and write, and hopefully it's always a good practice when we finish a module to go through questions, so that will help you, see if you can put together, answer some of these questions, and if you can, then you can go back, of course, and read to understand, so that when you are faced with the question, you can answer. So question 1, which type of EC2 instance is the most suitable and cost effective if the customer will be running mission critical workloads continuously for a whole year?
I think C.
C. Reserve.
I've sold myself. Okay, yeah, the reserve instances will provide you a significant discount compared to on-demand, right? And you can you purchase it for 1 year or 3 years. In Amazon EC2, which pricing construct adjusts its price based on supply and demand of EC2 instances?
I think it's A.
Okay, someone says A. Are there questions are there answers in the chat band?
Yes, Kenya also says A. Tatiana says A, yeah. Okay,
yeah, indeed, it's A. So you have the spot instance, which we mentioned that it's like the spare EC2 available capacity that will be available to you based on whether there is spare EC2, and it's based on the demand, supply and demand, yeah. So what are the contract length options for Amazon EC2 reserve instances? Select 2.
A and C.
C and A.
A and C.
Okay, can hear 3, A and C. Yeah, so reserve instances require a commitment of either 1 year or 3 years, and the 3-year offers a larger discount. One more question before I go. You have an Amazon Linux EC2 instance running for 1 hour and 30 minutes. How will AWS bill you in terms of usage? A, you will be billed for 1 hour according to the hourly billing rule. You will be billed for 1 hour and 30 minutes according to the hourly billing rule. You will be billed for 1 hour and 30 minutes according to the per second billing rule. You will be billed for 1 hour and 29 minutes according to the per second billing, according to the per second billing, yeah? You have a Linux EC2 running for 1 hour and 30 minutes.
2 people say C on the chat.
Okay. Yeah, so it's C. You will be billed in a per second duration. Yeah. So as I said, yeah, I have a hard stop at 7. I hope this was useful. At least I was able to pass the message through. And of course, if there are any questions, you can always come back to us. And there are many more questions here. When you receive the slide set, you will see more. So, and as you revise and on the topic of compute, yeah, hopefully this was helpful. Okay.
Great. Thank you very much.
Thank you, everyone.
Thank you, Maru. Mavero, sorry.
Yes.
Thank you so much, Ma. Even though we were too fast, but the information was well passed, and it's just a matter for us to take our time and go back again. Thanks.
Okay. Sorry. I hope for my next class, I will not have to rush, because again, because I was so conscious of that, I have a hard stop at 7. So yeah, but I hope when you go through the slides, it will, despite that I was fast, it will be okay. All right. And always come back for questions. And if you have, we are there to assist. Okay. But I promise in my next class, I will not be rushing. I still have one session with you people. So I hope you are not going to say, oh, she will be too fast. I will not be fast. No. Thanks for that feedback anyway. So yeah, thank you. No, nice day, everyone.
Okay, just a moment. Okay, thanks again, Vero, for that. Thanks for the presentation. And for everyone, I know much has been covered. That's why we record the sessions. So you try to look at it when you are back. And then also try to follow up with the presentation. So, but there's one thing before you go, I want you to keep in mind, especially for the session today. I see what's going on. So regarding, so this is one key thing, right? You've learned about compute. So the key thing is the whole concept of the key, to understand the key concept of what EC2 instances are as explained. What you should go with as a summary from what you've all heard is, remember from the global infrastructure, you have regions, you have availability zones. Availability zones have data centers, right? And in those data centers, you have hosts. So, and in those hosts, as Vero indicated, you have, these hosts have hardware, right? It could be the CPU, it could be the random access memory and storage. So these hosts run a hypervisor, and as explained, the hypervisor is the brain that kind of allocate the different hardware to the different virtual machines that are running. So keep that general picture in mind, right? That when you talk of an EC2 instance, it is running somewhere on a host in a data center somewhere in the world. And this data center is in somewhere in an availability zone. This availability zone sits somewhere in a region. I just want you to have that complete broad picture so that EC2 instance doesn't look like something very abstract. But so just wanted to recap that for you to keep, and then yeah, and then as usual, if there are any worries, just make sure that you bring back to us, okay? So as you notice, a lot of services have been touched, which is going to be a continuous process. So make sure that you try to read those services and understand what they are. And as we go along the line, you start getting used to them, because the definition of the services will not change. So SNS, if you know SNS, it will always be SNS. If you know what Fargate is, it will always be Fargate. That definition is not going to change. If you know what Lambda is, it will not change. So the key thing is, although there are many services, you should start taking them one by one as you go along. Make sure that you are capturing what they are and what they do. That's just something I wanted to recap and before you all go. Okay, so I'll stop the recording now, and then if there are other comments,